So let me introduce our panel for today. I go from that side to that side, from the right to the left. So on the right side, we have Markus Berg from the AOD Competence Center Production and Infrastructure. Next to him, Thorne from Sony. He's the category head for Networked Live. Then we have Phil Myers, CTO of Lawo. We have Geert, Director of Technology at NEP Broadcast. We have Klaus from Gas Valley, Director of Product Marketing. And to my left side is Dieter Bax from EVS. He's the VP Control and Orchestration, if I say it correctly. So, 6 panelists, 6 pages of questions and 60 minutes. Are you ready for the challenge? Then let's go. So what is software-defined production? Let's start with that. There's different views on software-defined productions. For some of them, it's an entirely software-based workflow in one generic hardware, so complete software like GVAMP, LiveOS, LiveView Studio, just to name a few. Others say it's more like a traditional architecture. You have several components. They run on a hardware, but on that hardware, you can deploy software to do some tasks. Lawo Home Apps are an example for this, although you can go further, I think. We have the EVS Neuron, which can do various tasks in there. So maybe the reality is even that we need to combine both things. Let's start with Klaus. You have AMP. It's a software-based production solution, everything. So how would you define a software-defined production environment?
Yeah. So first of all, many people think software-defined production is just replacing a given dedicated hardware solution by a solution where software is running on off-the-shelf hardware and providing the same functionality. So similar I/Os, similar workflows. That is, in some cases, a viable solution and also might offer some benefits still compared to traditional hardware, but that's not a complete what we claim or what we think is a software-defined production. A software-defined production should be based on microservices running on a distributed hardware platform, on one processing platform, where the platform can take care for additional services like managing the streams, providing security layer, and especially having a unified control solution in top, so that you can spin up service, spin down services, not only for one particular application, but for your entire end-to-end workflow under one control layer. Think about like iOS for broadcast, like having a platform where you can run your applications, your apps, as we call it in iOS world, and then have your full end-to-end production.
So brings me to Dieter. Should software-defined production be limited to, as I'm hearing, tools to cover audio and video needs? Or should we look at it more broadly, not only at the architecture, but also at how content will be produced in the future and where it goes to?
So, yes, I think I'm a bit biased maybe because I have a production background, but it's of course important that you look at the full production chain. We like engineering and technology to of course allow for that. And I agree with what they're saying, but it's important that we look at everything. There will be a change as well of how we operate, how people will use the tools, how we support them, and so on. So I think there is more to it than just the architecture and the pure processing as such. So that's what we believe is it's bigger than just the processing part.
So we should start looking maybe with the people who make content and first define what they're trying to do before we actually find the technology solution or deploy it.
Yes, and choose the right things for when you need them as well, because production will have needs, and those needs need to be covered. And so that's the production doesn't necessarily care what they're using in the background. They're trying to tell the story, and that's part of the whole journey. Of course, the infrastructure has to be capable of delivering what you need, but the user interface and the user experience that they have should also be considered.
Okay, so I'm sitting there. I still have my legacy background. how do I start? And that brings me to Markus. You are involved in the EBU Dynamic Media Facility Initiative. Will this initiative provide us with a guideline for designing media facilities based on software? What is the goal of that?
Hardware is still a great thing. So the EBU DMF is not a complete blueprint, which at the moment it's a building block box of systems which you can basically use then at the end to build software, but there is not yet a guideline. So if you start thinking about software-defined production, you must start with workflows and use cases. So don't replace, as I already said, hardware just by software and do the same things. You must think, how can I do more efficiently and new things, and then start thinking about what tools, what kind of designs could be. And the DMF is just one of the building blocks in this whole discussion, which doesn't cover all of the things. So some of the things on the lower levels will be common, IT, etc. So it's a kind of building box, but not a complete, full, up to the last GUI blueprint.
Yeah, so building blocks, it only works if the blocks can fit together. Lego works because it fits together. Phil, you're also involved in dynamic media facility from a manufacturer point of view.
So I think we start with the first question. If we're trying to just move the old world to the new world, we failed. The whole point of modularizing the services is actually to get back closer to the media functions and to bring a new way of working, which is what our customers are asking for, in an easy and simple way to deploy it. So yes, in the past we had very specific products to do specific things, but when you wanted to combine them to build a workflow, it was quite hard. So with software-defined production, what you really want to do is address the core problem, which is making the media functions accessible in a way where you can build the workflows for the customer in the most simplest and easiest way on a common set of hardware. The challenge that the DMF is addressing with the MXL, the media exchange layer, is you can't do building the media functions together if they don't all speak the same language in the pipes. And so we have to tackle the first problem, which is making sure that the flow of essences between the media functions is common in a way where we don't copy in and out of memory, transcode it, put it into Lawo's flavor, then into GV's flavor, or into somebody else's flavor. We want to make sure it stays in its native form as close to the metal as possible, so we can remove the challenges of orchestration, and we can remove some of the challenges like latency, for example. So that's really the first problem that the DMF will tackle. The other challenges are in the upper layers. So as Markus said, the lower layers is where we rely on commodity off-the-shelf technology vendors, the server vendors, the software ISVs that are making the containerized layer or the Kubernetes layer. And we're going to focus on the interchange layer first, the MXL. But of course, then you need to have the layers above of how do you know where it is, and how do you tell other media functions where to go get it from.
So while you're still building this sort of building block architecture, here on a significant sports event in Paris last year, you were already heavily involved in building and operating a software-defined setup. Was it based on generic hardware with functional components, or how did you do it, and were you able to cover all needs of a production?
Well, basically, we did what my colleague here next to me said isn't the way to go. We replaced the existing hardware with a server running software. This is for us this first step. This step had to be taken with this client production teams that aren't used to this new workflow. So we had to stick to the old workflows. So we built this hybrid environment where we are already working with software components, but built on COTS servers. So we're not generic hardware, we're on COTS servers. You can order them at a web shop in Dell. They will be delivered at you. You put your software on it. And then we integrated those those servers to each other with just 2110. We'll go into that later. The DMF project came out of what we did. Our question was actually, can we do this better? That's where DMF came in, like, hey, we've got this way, what do you think? And that solved for us a lot of things.
basically we had to deliver a certain products to the market. Viewers were watching it. Probably all of you were watching some parts of these things. And we had to squeeze ourselves in between, and we managed to deliver everything. Reliability was our main concern in this whole approach. So we had a spare service, we had spare parts of everything. A little bit like you would now do with an OB van. You would load some spare stuff.
You still
in
had an
generic
SDI
devices.
truck around the corner just in case? Or
Excuse me?
you still had an SDI truck around the corner just in case?
No SDI. No, but basically there wasn't a black burst signal. There was one black burst signal. But basically we managed to do everything. So we managed to take this first step to show production people that although we as a technology are moving forward, and we're moving forward towards what Markus and Phil and Klaus told before, that is where we want to end up. But we have to first take a step to prove the world, because we're all legacy engineers from somewhere, to prove this is possible. We can take this next step, and that's what we tried to do in Paris. And it worked, because we went on air and we had zero errors.
Did it lead to production teams starting to rethink if they could define different workflows?
For certain functionalities, yes.
Okay.
They were definitely looking into, like, can we do this now? Can we do that now? There's certain things like EVS. They're used to this box that if they do this, it rewinds. If they do this, it winds forward. If they hit play,
Does a bit more.
those
but
things they're not willing to change immediately.
Okay. Yeah. So Phil, at Lawo, you have VSM as a control system. At EVS, they have Cerebrum. These were the tools which we use to configure our production infrastructure. Will you say that these tools will evolve now more to process and workflow building tools, or will they just be a layer beneath something that will come on top of them?
Yeah, so we highlighted quite quickly that the broadcast controller has a fairly defined requirement. It's mainly to build, I would say, more the operators facing workflows. But if you really want to adapt this technology, the intelligence has to sit in the layer below. Because the reality is, if you're going to end up federating sites or federating customer installs, you can't guarantee you will always have the same broadcast controller sat on top. And so, therefore, things like dynamically moving functionality, just simple things like IP address management, auto spawning, protecting of the services, all the benefits we get from the IT infrastructure, you shouldn't try and shoehorn a wooden peg into a round hole. And trying to bring the broadcast controller down to do that seems a bit brute force. The broadcast controller really has a very specific use case, which is to abstract all the complexity away from the operators. Because the reality is, the operators actually don't care what sits behind it. They just want to have zero impact from their operations. So I think that what you will see, and you'll see that from a number of vendors, is they invest in the layer below. Because, and maybe orchestration is the wrong word, because when we always hear orchestration, people think of network orchestration, but it's you need to be able to provision, manage that layer, and it's a different tool set, and it has to be really simple, because you might not have a broadcast engineer sitting doing that. You might not even have an engineer sitting doing it. You might come from a scheduling system, which means you have a very non-technical person provisioning a bunch of resources for production for a set period of time and then taking it away. So I think you'll see an evolution in that middle layer, and I think what I would say you'll see from the likes of what we're doing with VSM is we'll put more investment in the operational front, making it easier for the operators to see the workflows, build the workflows, the things that have the biggest impact to an operator.
Yep, because the whole thing about workflows and is flexibility. That's the advantage of software-defined. Klaus, are the current software-defined production solutions, are they already providing enough flexibility, or do they need to be adapted to a wide range of production workflows, given there are so many functions involved in a complete end-to-end production?
Yeah, so our solution has been developed from the ground up to be a flexible and open system. So it is not a closed system, even though it's mainly coming from us as the operation system, but the API is public. Software development kit is available for free. So we have more than 300 native apps already running on the platform. So and not all the apps coming from Grass Valley, many of them coming from third parties. We work with partners developing their own apps for automation, for subtitling, for graphics, for editing, and so on. So we provide a flexibility by the openness to the market. So we still want and need to take care for certain, let's say, functions in the top. So the user interface, which should be common. So if you want to spin up and down a service or an app, it should be done on one platform and not that you open up multiple different windows to spin up here a service and then another window for another service and then interconnect them together. No, it should all be one function. And this is what we believe the platform should provide.
Yes.
How you build up your workflows, this should be completely flexible. You should be able to build any workflow as you like, all under one software layer. And in example, I also heard this morning, it was somehow already mentioned, there is a big installation at DMC in Hilversum, which is a full end-to-end broadcast facility with multiple different studios and control rooms and so on. It's for a big sport channel in the Netherlands. And the whole infrastructure is completely running on software and all in using microservices for providing the flexibility. They can spin up and down services just as required. So the flexibility should be built into the solution you are choosing, whatever it is. Of course, we prefer it is ours, but even if you are not going for whatever reason to our solution, the flexibility is a very important thing, and it should be one, let's say, control layer which allows you to build your workflows as you need them.
Okay, brings me to Dieter and to Rob. Let's start with Rob, because the workflows, and we can design them now different than they used to be in a legacy of it, infrastructure. That impacts the staff. Do you think people's role will change from monolithic to be more multidisciplined, to be available to do more different things?
Yeah, I think there's a kind of a shift depending on your function. If you look at engineers, for example, they're by nature multidisciplinary. They have to do video, audio, replay, networking, and their remit is going to become broader, but actually in some areas fundamentally different. Some of the things that, legacy-wise they had to be concerned with, if you go back to analog, worrying about reference loops, worrying about tuning monitors, there's a lot of skills that the engineers have that they've proven over time they're able to translate. And I think when you go into the more software-defined production space, those same skill sets are going to need to be translated into new functions, new language. Video engineers in a engine room, as we've all mentioned, isn't going to be about whether their system's running on COTS next to them, on public cloud, private cloud, or traditional hardware, but they need to be aware of what's going on around them. And then you kind of got the architectural conversation as well, how you design these systems to meet the needs of production, and the need that there's going to be there is an education piece from manufacturers, but also from the IT industry as well. Kubernetes, Dockers are all very well-established technologies, but they're just new for us in our linguistic tool set. And I think that there is going to need to be a fundamental education piece for engineers, especially because obviously if something goes wrong during a production, the first people the production team turn to are the engineers. What's going on? What's happening? So they need to have confidence in the technology and in the solutions around it that are helping them interface with that technology. Because today it may be next to them in the truck, tomorrow it may be 100 kilometers away.
It's your view also, Dieter?
Yeah, I look more another layer on the production. So you talked about engineering and so on, that indeed will change. On the production side as well, I think what we're trying to do is produce as much content as we want. And also what we try to do is, doesn't matter if it's software defined or not, but of course what you're trying to do is do as much as you can with the infrastructure that you have. So you're going to try and do a production podcast or maybe a full production or whatever with the equipment that you have, so you can optimize your total cost of ownership. What's important is that the people that are sitting in front, that they don't have to move to another control room, or they need to, that basically they are familiar with the interfaces, so that the interfaces can basically operate in the same way if you maybe do a podcast compared to the 7 o'clock news. That gives a certain flexibility, and that will help in also using your staff better, because you cannot, I think as an industry, it's going to be hard to say, okay, I can only do vision mixing. That's my only function, or I only do this, or I only do that. We see more dispersed roles, and we see also that more younger people that come in the industry are open to being that flexible. And so it's the combination of the back end and the front end that will actually give you that whole flexibility on being dynamic. And I think that's how we can optimize everything, and then you can even go a step further and look at automation. Can we complement with automation? Because if your role is changing, and like you were saying, you can connect two engines together, two functionalities, well, can the person do that at the same time, or can I automate a part of that?
Yeah, makes sense, because in normal software, we don't have a Word operator and an Excel operator, and you need to do a bit of everything. Rainer started with talking about change management. Geert, you experienced firsthand that many legacy engineers adapt quicker to software-defined production engineers than IT staff getting broadcasterized.
Yeah.
The reason for this, and I quote you, is because traditional broadcast engineers are more used to blank pages. What do you mean by that?
Yeah. What do I mean with that? So broadcast engineers are used to always changing environments. So when they are out with a truck, especially when they're out on a truck or on live events, it's never the way they designed it. It's always different. Whilst on the other hand, IT engineers are more in strict workflows, used to strict, this is the workflow I follow, this is the frame I follow, the work frame, the framework I follow. So that's what they're used to. On the other hand, back to the broadcast engineers, they're used to system timing, signal flows, and all those things. They actually build each time a system from scratch. An IT engineer will usually not touch something that works and try to adjust as much as he can this thing. I've had both in my team. I've had both where I had to work together. They sometimes had border conflicts, of course, but in the end, the IT engineer learned from fluidity from the broadcast engineer. Like, I don't actually have to stay within the borders. I can sometimes be creative and solve it this way. And the broadcast engineer learned, like, hey, there's actually working within borders actually helps me getting things quicker done and better done. So I saw them merge together into a hybrid person. So the broadcast engineer in the end was CLI scripting, and the IT engineer was patching things. I was like, hey, what's going on? But in the end, the team that that built the Paris kit, they're at this moment my most important assets, because they learn from each other and they can easily adapt and create new things. And that's what I mean. A broadcast engineer, I saw him easily adapt than the IT engineer. I'm not saying some workflow is wrong or better than the other, but as we've done HD, UHD, all those changes, we're used to like, hey, wait, this is we start from scratch, blank page, every production we do the same, and we're used to that. So that really helps in the software-defined programming.
So we can conclude that everybody who's still working in the legacy world don't need to be scared of software-defined production. There's certainly a place for them to find a job in there.
It's a new tool set.
It's a new tool set. Cabling the software. Some questions for our vendors, because we need to glue, as we said earlier, different bricks together, and that become a challenge when taking the multi-vendor route, where we're going to combine different things. And it's what is exposed, as Klaus already mentioned. What is open will determine the end result. Is it a need to standardize everything, to really strictly standardize, or is there a different way of doing it? Let's start with Phil.
Yeah, so I think, what's the political response to this? So, so we have this thing called 2110.
Yeah.
That's a pretty good standard. Did it go as quick as what we thought it would go? No. Do we have to live with it? Yes, we have to live with it. I think what you're going to see, especially with the work with the EBU and the DMF, is we're going to move a lot quicker using other practices that work far greater in other technologies investment areas. So open source, a lot of vendors use more open source now than they've ever done. And I think a lot of the development programs now will fall into that model, which is adapt quickly. So build, adapt, change, adapt, and build again. So I think that will become more predominant in our industry. It doesn't mean standards will go away. It just means that in order to achieve progress, which is what our clients are asking for, we'll have to find a different way, which is a more agile way of working, which actually means that the things that we do have to align very closely to what the customer problem we're trying to solve. What that also means is it will force vendors, quite frankly, to work differently than they have in the past. So the plus with the standard is everyone unanimously agrees to something and we go and do it. The downside of that, we all interpret a slightly different way, and then we come together and it doesn't quite work as we thought it would work. So in this sort of open source model, you're kind of working together collaboratively to get to a common outcome. What I think we will see is the next evolution of that. I don't think we will get a standard or a common API above. I think what we'll do is move more to the models that we see in the cloud space, where each cloud provider has a well-documented open API, which means that ultimately whoever's really at the top of the stack, the orchestrator, the broadcaster, will be able to implement any of the things below, because all of the APIs are well-documented, they are open, and they provide unrestricted access to the functions that they need to do. So I think that will also shift slightly differently to the way we've done the VAS. Because equally in that space, we've spent about as much time trying to make MMOS be rolled out across all the organizations. And I think we succeeded very well in stream patching. But when you look at all the other things that are required in an end-to-end workflow, I think you can look across it and say, well, it's not quite as well adopted as possible. So it probably tells us that if you follow the same path, why would you not get the same result? So I think we have to think slightly different about, because I'm of the opinion our customers waited long enough for the IP transition, they won't wait the same time again to make the software transition. So we're going to have to think about how we can speed that process up.
So the future is to the DevOps, Rob?
Yeah, I think this... Oh, sorry.
I think DevOps definitely has a place, especially when you've got multi-vendor, multi-provider environments being deployed for customers, and every single broadcaster has their own skill set. Some have a lot of DevOps internally, some don't. And it very much enables you to make the workflows fit your unique requirements, whether that's linguistics, operator interfaces, scheduling, all of these other kind of external factors to the traditional linear broadcast pipeline that now need to be considered. But kind of to mirror what Phil was saying, everything is about doing more with less, faster. Standardization's great, but it's, designed by committee. It doesn't kind of deliver results quickly, although they are and can be quite efficient, but kind of, designed by code and trial and error almost. Develop everything from an SDK to kind of support the workflows that are needed, to kind of create the glue products that sit in the middle to blend a Sony and a Lawo or EVS or GV tools together. whilst the manufacturers also do that, but for some people, manufacturers have got other priorities. We're global entities, so actually DevOps can fill that void for the local requirement quite nicely.
From a Grass Valley point of view, do you see the same way, or do you say no, our platform is where we will actually make sure there is no need for DevOps to have all the things working in there?
Yeah. So first of all, as I explained, we see a lot of benefits on using a platform with microservice. Still, we are perfectly open to work with bodies like the EBU, and we are one of the supporting members for the MXF standard. So we basically use it internally to exchange content between multiple servers if you need to go away from one server to multiple one because of the requirements you have on your processing. So, and the thing always with standard is it's always the challenge between to find the right balance between make the standard quite limited and strict and keep it open, because if you make it too open, offer too many flexibilities, you have maybe 3 different vendors all fully fulfilling the standard, but they're still not talking to each other. And if you make it limited and strict, then you might miss some flexibility. So, but we are more than happy to support standard bodies like SEMTI or EBU or others to define a standard which helps us as an industry to better work together. Phil mentioned open APIs. I totally agree on that one. That's one of the reasons why our API is public. So, and why we invite anybody to work on that one, which some competitors already did, like even Ross just recently have built or developed applications running under AMP, and we are more than happy to invite any other industry, let's say, body or company to work on that.
That's the same for EVS, I presume.
Yeah, it's the same. I think that's where we actually, what's interesting as we move into this software world, we're actually integrating more and more. I mean, in the past, there was the standard protocols, very basic routing, but more and more we integrate into the same thing, to GV, we integrate into home, we integrate into the different controls. And it's not just routing, it's every end device control and all of that. So I think for us, it's using that, but also trying to leverage as much the open standards where it makes sense, right? I mean, Phil talked about the interchanging of control systems. If you have multiple control systems, leveraging their NMOS and the open standards to maybe hand over items. We've done that as well, even with NEP. So you have to try and leverage the right tools. And in some cases, you will need DevOps to do some additional integrations that are specific to the workflow that they would like to achieve.
Okay. Yes, as a service provider, do you see your role also changing from becoming the one who actually makes all the connections between the software components as, let's say, the software integrator instead of the system integrator?
Yes, definitely, because we bear a certain operational responsibility towards our clients. We need to get the program on air. Whilst before we did this with patches and rack and stack everything we needed, I think while we are choosing our solution for our clients and building the solution for our clients, we need to be able to choose the best of breed software. And by doing that, it automatically involves that we need to create a kind of orchestration layer, which NEP built themselves with TFC. And that orchestration layer will take care that APIs from Lawo and EVS talk to each other. We will be the intermediate layer to have everybody talking to each other. In the end, it's due to the responsibility we bear to deliver a project on time. And we not always get immediate response from vendors straight away without wanting to hurt any feelings here.
As long as you pay the SLA, it's okay. It's about software, so let's talk about hardware. This morning, or before the panel before in the on sustainability, they had it about FPGA, how it helps to be consume less energy. The question is dedicated or generic hardware to run our software on. What we could say is, for example, a vision mixer used to be in the past a metal box, and the vision mixer was sitting inside that box. Now, if we're going software, we actually go behind, let's say, further than just the limit of the box. We can virtualize, we can go outside that. It can even be in different locations, part of our vision mixer functionality. Maybe question to all the panelists to do a small tour. Should SDP solutions be designed to support a decentralized setup? And so that we can leave the boundaries of a server, and what technologies should we then use for that? We start with.
I would say yes, because then we could more focus on for what kind of production we could choose, what kind of blocks to make it, on what technical infrastructure. So I would say I'm a little bit too far away. It should be at least easy enough for us to implement. And looking at those new things, we also have to look at our investment circle times, which also very often don't fit to innovation. So we must be able to add more things in the lifetime of the basic infrastructure we have. So this is a topic of migration also, but it should be capable of being decentralized for us to pick up for the right production, the right tools. But to be honest, I'm a little bit too far away from technology to say, okay, this is the best platform. So I would give this question more to the colleagues of the vendors.
Who's closer to technology to give an answer to that? On what technology should we use to actually do that?
I'll give a go at it. So I think if the goal is just to put every vendor in a single box, that's just like putting multiple modular vendors in a similar frame. That's not the holy grail. We will need to go beyond a single box for a number of reasons. One, over the lifespan of an IT investment, you might start with small servers and they get larger, and they might not all be available at the same time because of utilization. So you're going to always have to be able to spread your processing over a number of the nodes. The other side of it is this vision mixer model that you talked about. We still think of vision mixers as these large frames with all the I/O on them and the MEs. But at the end of it, it's all about how many pictures do you put into the final program at the same time. And if all the signals are in the network and I can get them from the network into the compute box, I can eliminate the need to have every single signal be terminated on one big frame. So that comes to different ways of working. It also comes to having a lot of glueware to up, down, cross, HDR processing. That's equally in the chain before it hits the vision mixer. So by having one common set of infrastructure and be able to spread it linearly, not only do I get the optimization and the scale, but the problem will then come of, okay, how do I get first part of it to the second part of it? So that we shouldn't boil the ocean and reinvent the wheel here. And there are technologies like RDMA over Converged Ethernet using libfabric. That works actually in a very similar way, where we want to do exchange of large language models between high compute processing nodes. And so we should leverage that technology. It's well established. It's been around for many, many years. And it's more than capable of delivering what we need to deliver. So the EBU stack is pretty clear on that the underlying layer is to address that problem. And so I think we've heard it from conferences like Devoncroft, where we as broadcast vendors should just give that up. I think we already start giving it up with the introduction of network switching and now with general off-the-shelf compute. In the reality, there's not a lot of value that Lawo can bring to a box that's just a Dell server or an Arista or Cisco switch fabric. Where we can bring the value is the layers above. And so there is technology there, and that technology is used today by several of the vendors that are here today. It is not built by the media and entertainment space, so it's not bespoke to our industry like some of the SMPTE standards is. And it evolves way quicker than what we can, because the use cases outside of media and entertainment are far bigger than even the biggest ones we can think of. So we should really leverage that if we want to accelerate that. And so I think you're going to see the industry, after we get to a minimum viable product with MXL, will quite quickly converge on RDMA and libfabric as the interconnect model between processing nodes.
Yeah, Geert, you're also a big fan of RDMA?
Yes, whilst 2110 is good for contribution and distribution between these different clusters of processing power, like Phil just tried to describe. I think within these clusters, within these inter-server communication, we need to do that in a way that we've got zero latency. We don't need to hit the processor, and every application that is working on those same video and audio essences need to have direct access to it. So that's where I believe this RDMA solution or all the loop recording solutions that the Digital Media Facility is trying to define is helping enormously to work towards the microservices solution.
Can somebody, maybe in interest for the audience, also explain in 5 words RDMA, what is the basis of that? Or is it not possible in just 5 words?
I don't think you're going to explain in 5 words. So I think that the best way to explain is how do we do it in an IP world? So today we take a traditional baseband signal, we put it in a gateway, we packetize it, we move it through a network, we process it, we packetize it and move to the next chain, and we keep repeating that until we get the finished product at the end. The packetization process is actually quite expensive, not only from a compute perspective, but it's also adding latency in every time you go in and out and in and out. And so what RDMA does allow us to do is it says, okay, I put it into memory once, and anybody that wants to consume it can get to the location of where it sits in the memory. And that can either be inside the node itself, or it can be in a remote, hence remote memory accessing. So, and that means that we eliminate unnecessary compute, we reduce latency, and we can be much more efficient, even at a control level, where we don't have to think about all the complexities in the routing paths. So I think there's a lot of benefits for it, but it does bring some other challenges, like rights management. Who's using the memory? Who's using that addressable memory space? Because you don't want to flush it while somebody else is still accessing and doing stuff. So, but that's really no different to, I explain to people like files on shared storage. You write it once and you read many. It's kind of the same concept. And that file can be distributed in one node, or it can be cloud distributed across decentralized storage.
Okay, after signals, we had streams, and now there's something else again. Yeah. Luckily, we are used to starting from a blank page. Now, with software comes the fact that software can have bugs. We can have firmware upgrades. There's the fact of redundancy. You don't want to send a blue screen of that to your audience on a certain day. So software issues could result from upgrading the hardware's firmware, and every install has specifics. Hardware is not always as generic as we think it is. How should we handle upgrading, firmware upgrading, redundancy? And I'll start with Rob.
I think kind of going to the point at the beginning, it's all about change management. And, some customers like a model that's kind of very well adopted by IT of pre-production. You have your sandbox environment that has samples of equipment that you may be able to bring a camera in to test a particular piece of firmware. And, traditional systems, you've had to take stuff offline to upgrade it. You're not upgrading individual packets or packages on a big system. You're upgrading everything as a single monolithic slab. And what more modern architectures enable us to do is just do individual components, individual containers of functionality that mean that you could do more of a kind of a canary model where you update a single bit of your system that may be not being utilized that day. Upgrade it, it's very quick to roll back, and then you can replace it if something has gone wrong in your implementation. And I think it all boils down to risk and whether you're prepared to have a complete set of equipment that's sat in a lab that's sole purpose is pre-production, or whether you're prepared to take that risk of in downtime of Studio C, you can then upgrade core components in a very granular level. And it boils down to that risk piece of, okay, what fits your business model about your utilization of your services? It is a consideration, especially when you look at security patches being one of the key ones that most people have to update, and interdependencies, especially when using open source, things need to get fixed. How can we make that as simple as possible. And that's something that us manufacturers have to kind of secure. And by using containers, as I said, it does facilitate small incremental upgrades rather than massive software releases that cause several reboots as part of that upgrade cycle.
So Markus, straight from the beginning, when making your architecture of a software-defined platform or solution, you should already prepare for staging for upgrades. You should include that in your overall design.
Yes, and especially learning from the migration to IP, we are extremely happy having some test and staging environments, because even if you have a piece of software upgrade which is perfectly working for this software, it could affect other software tools which then maybe miss or have a new feature which they cannot cope with. So I'm always in favor, if we have enough money, to have a kind of test and staging environment. What a lot helped in this old IP stuff was the JTNM tested session. So maybe I'm not sure if we should do something as big as JTNM tested for this stuff, but maybe some sessions where a lot of manufacturers come together and test certain things could help broadcasters also configuring their test systems for the future, and could save them a lot of money making bigger tests once, and not everybody should make the same tests that then others already did. So this could be a thing. I'm not quite sure about it was a big effort at this time. It was in IRT, I was involved in a lot of JTNM tested stuff. It was great, and it helped us at broadcast to choose the product and to choose also our test environment. So yes, we need something. The size, I'm not quite sure.
So especially multi-vendor setups, Dieter, you will all develop your components, and then to discover if they actually work together, not only based on what we think they will do. Is that something that the end user will discover once he starts bringing the blocks together? Or should you, as vendors or producers, as an industry, prepare for, let's say, like we used to do the interrupt tests in the IP world? Is this even more needed now that we move to software and that you start talking to your peers in the industry?
What we at least try to do as much as we can is try to do pre-testing, but you have to be realistic. There is hundreds of vendors out there, so it's quite difficult from time to time. But we have what we at least call preferred vendors, or the one that we have bigger integrations with. If we take the example of with Lawo and NATS protocol, it's way more complex. So we do in those cases more testing. We know, of course, what we test, so we can also know what has changed. I think the testing as such is happening. We also see a change in like service providers. What Geert was saying is that very often the type of customer is also going quicker in some upgrades. A service provider will be quicker to go to the latest and greatest compared to a public broadcaster who is basically going more in a day-to-day 24/7. So I think it's going to be, no matter what, a mix of different things. But I think it's inevitable that we will have to work together, because in software, it is something that just evolves way faster. We're not yet in a world where we just plug and everything will work. On the other side, internally, what we also need to do is that make sure that if we build these connectors, that they don't harm the core. If I explain it well, is that you have to make sure that maybe the connection could stop, and then we come back to what Rob was saying about you can roll back to a previous version or anything, but you need to assure that the core of your system is not impacted. So it's going to be a combination of, I think time will tell as well a little bit.
Yep, because I think, Klaus, you have this orchestrator or your platform on which runs everything. There's different third parties running also on that. Of course, your platform will go to higher versions. Your third parties will also move to higher versions at some stage. How can that be managed to actually make sure that the version higher from your third party is still working with your lower version, vice versa? Or
yeah, for us it's the same challenge as you told with testing. For us, internal software testing is one of the most time-consuming element in development. we spend in some areas more time for the testing than for the development of the new software. But we had that already for the hardware solutions, the same thing. But this is also one of the, let's say, advantages for the customers. Once you let the orchestration layer or the platform, or as we call it, manage your software updates. So we make sure that the latest software patches are on the AMP platform, and we check, of course, internally that whatever we update does not interfere with the applications. Of course, we cannot test any application from any vendors. As I have mentioned, we have 300 or more than 300 native apps. You cannot test all the 300 native apps, where maybe half of them are not made by us. But then it comes back to the API that you need to define carefully your interfacing, and then you need to, of course, rely that if one of the partners does an update, that he does his testing as good as we do our testing.
Geert, do you think a software-defined solution where you have this all in one, so you have one software package that does anything from your replay until your play out, even your streaming, is that easier to maintain than going a multi-vendor route?
Well, it all depends on your end client again. If the production is a quite lower tier production that doesn't need that much predefined workflows, then these all-in-one boxes can deliver you everything you want. But when the thing we did for the Paris sports event, there we needed the best of breed in every software. So there we needed to combine all these softwares together. And that's where we really needed our DevOps people and our system integrators and our network guys to work together to get all these little APIs talking to each other, to get all vendors talking to each other, and to get this. So there's advantages in both systems, and you need to look at does my client want? What do I bring to the table? And that has a reflection in the price and the support you give the clients.
Finally, something about business. Software-defined production will impact the roles and services of the various stakeholders. There's a lot of things changing. Broadcaster vendors, those traditional roles might disappear. One could even say that if it's just a software, I can gather a team of freelancers and say, okay, for this production, we'll fire up the softwares, and instead of renting an OB truck, we just deploy it and here we go. Are you worried as a service provider here that your business will go away?
No, to be honest, it's the same story again. If your client says, I will bring my own equipment, he takes a certain operational responsibility. Does he want to do that? Is the price transparency worth giving up some of the responsibility? And I think we will always bring the people aboard that need to have everything talking to each other. We will always be there to deliver solutions to our clients. And if they want to bring their own equipment, they will take a certain responsibility. We will support it, but it will take a certain price. So it will be the same story. The business might shift from here to there a little bit, but in the end, it will stay the same story.
And if it's software, somebody still needs to buy or rent the hardware or book it, which it's running in the end. So if it's cloud, for example, you said, I think it was you, Rob, that this could also have an impact on the cost depending on who's actually booking it. For a single smaller operator, it might be more expensive than if you, for example, as a big organization would provide those instances.
Yeah, I think there is a fundamental business model shift that needs to take place because, the likes of Sony do have a different price per hour compared to broadcaster number 6. Everyone's at an Amazon and a Google perspective is based on your usage. And I think you then kind of have to factor in security models. And, you know, are your security models aligned with what Sony do on their platforms? Does that give you the flexibility on operations? So there's multi-tiers to it. And I don't think there's one right answer yet, whether manufacturers host, whether broadcasters host. Everything boils down to a complex matrix of variables. And then you get into the whole data privacy. Where are you physically storing data as well? All of these different things come into this model that make it really difficult to say it's actually cheaper to go manufacture cloud instances versus local, because there's all of these different variables.
Markus, will we, is to Markus the question, will we go to something like media infrastructure as a service?
Well, at a certain point of time, yes, but I would like to mention, especially public broadcasters have then to make a kind of investment and cost circle change management, because traditionally we bought a big expensive piece of hardware, installed it, and for 20 years we didn't look at it. And now sometimes we're not prepared to this new kind of cost planning, cost deployment. So this is something which must take into account a kind of really investment change management. So it's a good way to go there, but sometimes the road is not yet cleared, and there are some red lights still that we have to cover.
Well, and as we are talking a little bit about business now, Klaus, when I was talking earlier, we had it about workflows. You mentioned at one stage that like billing can be part of the workflow or integrated into the platform. Can you elaborate a bit on that?
Yeah. So that's, of course, also an important part when you think about your software-defined workflow, is how to control billing, how to manage. So in case of hardware, it was simple. You had a box, you know what it cost, and then you could do your calculations, how many years you want to operate it, and then you know how to do your investments. But this is also an advantage now with software-defined productions. You have a much lower upfront cost. You have, of course, more OPEX, more operational costs, but less investments. So especially for all the ones who want to start now to establish a new service, or even for a public broadcaster who is now at the end of the lifetime cycle of a certain hardware, you have a choice to replace that hardware by another expensive hardware, or to invest into lower cost COTS hardware, and then, which is a much lower investment now, so you can do it with less budget now. Of course, you need to blend your operation cost, which will then occur while you're using. But the good thing is, the cost only occur when you use it. If for whatever reason your business model is changing, or a certain production will not be continued, you don't need to pay for it. Where if the hardware is bought, it's maybe collecting dust in the corner and it doesn't generate any business. Yes, well, it was paid once, but on the other hand, it does not help. So, but coming back to the management, if you have multiple different, let's say, isolated solutions, all does something, a virtual production switcher, a virtual replay system, a playout, a content management system, and they're all not connected, maybe from different vendors, you of course have to pay for the running cost for A, B, C, D, and that might be different and changing. If you have a solution which is running under one platform, you have a billing which takes care for all the services, even if they are from third parties. In case of AMP, you have tokens, and you can pay as you go. You pay only for the service you use. That's the most expensive one if you use it frequently. But coming to more your business model as you have it today, you can also do subscription, where you say, okay, I buy now this base hardware, which can perform like a switcher with a certain replay or multi-viewer functionality. And then you pay for that function with a subscription fee for 2 years, 3 years, 4 years. And then you can basically calculate the lifetime cost of that operation. That's the other model. And we have also monthly fees and so on. So you have all the different scales of payment. That's another advantage of software-defined production, that you can select the right model which best fits to your workflow. And that might be different for a typical public broadcaster compared to a service provider, maybe compared to a company which only does whatever special events, for example, once every year, or like Olympics, once every 4 years. That's a good example where maybe a pay-as-you-go model would be perfect for such an application, where maybe in your case a subscription fee would be more sufficient.
Okay, so we should include the return on investment application running on the platform in real time to see are we making money or still losing. To wrap up the session, we're going to do a small tour because, okay, we are now convinced that software-defined production is the way forward, but how should we migrate them? Here on the panel, do we have any tips or recommendations? I start with Dieter.
I think it's still, yes, it's the future, 100%. But it's going to be a transition. And that's also related to the cost, is that you have to look at the TCO as well of your investment and everything that you do. And there's a cost, of course, on licensing, but there's also a running cost, power consumption, and all of it. So it's a difficult calculation, but I think we're on the track. And I think, every broadcaster will have different needs. So I think everybody will also move at his own pace. So,
Klaus, what would you advise to anybody who wants to go software-defined?
Yeah. I would recommend everybody, when he's starting a new project or a new planning, to carefully analyze what are the pros and cons for the different solutions. And in case for the application they are planning, software-defined workflows would fit. And even if the overall, let's say, calculation would say, well, it's maybe the same or maybe even a few % higher, I would still recommend go for the software-defined solution, just to get an idea how it works, to gain experience, to operate it. Very likely it would be not maybe the most demanding application the customer is doing. Maybe try small and grow, but gain experience. So, and what we have seen, most of our customers who tried, they really learn the benefits and have seen advantages and have grown with the system. And this is something I can only recommend to the customers. Try to find an application where it fits and do it. And see how your operators is managing it. See how the organization can cope with and grow from that point on.
Geert, you already have done part of the way to transitioning. You must have a golden recommendation for people based on your experience.
Yes, from my point of view, define your projects upfront very well. What are your requirements? What are your minimal requirements? If you've got that at hand, build a team of legacy people and new newbies, the new young guys, as I call them. Then choose for vendors with an open mind, with APIs, open mind, that are willing to cooperate with other vendors. And third of all, and that's maybe a funny one, think big, start small, scale fast.
Okay, you all wrote that down, I hope. Phil?
I would always start with challenge yourself. So as an industry, we've always just rinsed and repeated. We built it this way, so we'll just keep building it that way. And you just ask a couple of simple questions. Do I know what I need now, what I need in the future? And in the rapid technology shift that we've had over the last couple of years and the outlook going forward, I cannot believe that every customer knows exactly what they need going forward. If you look at the rise of the content distribution market, the other question I ask is, do I actually need all of this equipment? Because a lot of customers I go around, they've built facilities 5, 10, 15, 20 years ago, and most of that facility sits dark half the time. And a lot of customers are scared to turn it off because most of it, they're scared they can't get it back because they don't have spares or there's no software support anymore. So, and that goes really against sustainability, by the way, because then you're burning all of the the computation and the power coming with it. So I think you've got to have a really open mind, challenge yourself, think slightly different. I think the lesson learned from the IP transition is a lot of the early IP projects were just people trying to build SDI infrastructure in an IP domain, which utterly was the wrong way around. And so you end up over-speccing it, you end up doing workflows exactly the same way, and our customers don't have tolerance for that anymore. So I would really say, sit down with a blank mind, blank sheet of paper, think about what you're trying to achieve, have an idea of where you think you're going to get to, but make decisions that allow you to be agile and move forward. And don't always say, oh, well, if I do this, I know it worked in the past. Look at other ways to do it, because for sure, workflows will change significantly. And that's not just because the tier 1 budgets are coming down, as the tier 2, tier 3 budgets expect the same quality as the tier 1. So you're going to have to change whether you like it or not. So really, it's about having the open mind and thinking through what are the goals you're trying to achieve.
Rob?
Yeah, I kind of agree. And one of the common themes I've heard is, potentially hybrid is king. It's work out what your project needs are. And, not many customers are blessed with greenfield. Most customers have got to upgrade what they've got. So actually analyzing what the needs of that upgrade are. Is it replacing component 1 and component 2? So multi-viewers, for example, we just need to upgrade those and free capacity off. Great, hybrid. Or is it actually, I'm going to upgrade this complete studio? Again, hybrid. Understand what you need to do. And if you're going from an SDI straight to software defined, that could work. Or you may have to have an intermediary like IP. All of these different technologies are there so that you can not only educate the staff, increase the confidence in it, but also adapt quickly as you need.
Finally, Markus.
I think everything has been said, because look at your use cases, look at how you may want to produce in the future, and then try to migrate step by step, because a big shift, I agree with, doesn't work, but try to find something which brings you a quick benefit. There are use cases and productions where it can bring a bit benefit, and then a little point to all the vendors: make it easier than the migration to 2110. This would help us getting faster on this train. But I think looking at the use cases is a very important point. As we mentioned, not replacing the SDI workflow with the same workflow in software. This makes it more expensive.
What I learned from talking with you was, don't start from the technology point of view, start from the production point of view of what I want to achieve, and then see how you can use technology. Thanks, gentlemen. We run only 9 minutes over time, so I think we did quite well. Give them a warm round of applause.